Don't get me wrong, the message of this video is not to never care about optimizations and write bad software. It's quite the opposite. But beginners really have a wrong idea about optimizations, and it's not their fault, this is a hard topic. Look at this example here. I just removed the comparison from the loop. This is a classic way to optimize the code, but the result is 2 times slower. What? Don't worry, I will explain how that was possible. So this video will help you decide when to optimize, and instead of optimizing, I will teach you to do something called not pessimizing your code. So let's go. First of all, what does it mean to optimize? People actually have slightly contradictory definitions. But to optimize means to measure the performance of your code and then make some changes to try to improve that performance. You have to measure your code if you want to optimize. This is extremely important. And yes, there are cases where you don't have to measure your code, like reserving the known size of a vector. It will improve the speed significantly. And if you know the size to reserve, you don't really have any reason not to do it. But most things are not this simple, like the example I gave at the start of the video. Let's start with high-level optimizations. This includes things like changing the algorithm that you use, reserving your vector, and caching some results so you don't recalculate them. And you need to understand 2 axioms. Your PC is fast, and nothing is free. And we'll look at a specific example. In my Steam game, I can shoot arrows at this target to change the state of all these red blocks. The optimized approach would be to have a list of all the places where there are red blocks in the map, and iterate through it. This is called caching. But I didn't do it. I just iterate through all the map data. And the map can be like an array of 800 by 400 blocks. And this is the first thing that you need to understand. Your PC is extremely fast. This slow implementation is still so fast that it's impossible to notice it. Like, imagine I gave you 2 versions of this game. One with the optimization and one without. There is no measurement that you can do to determine which one is the first version. Not to mention that I run this code only when the trigger is hit. So you need to ask yourself if that part of the code needs optimization. If this slow code was run every frame multiple times, maybe then it would matter. But the golden rule for you as a beginner is to measure your code. It's not okay to think that iterating through a large array is slow if you have never measured it. At least maybe have a FPS counter for your game and see if your code influences it. Okay, but now you might say that, okay, sure, the optimization wasn't that useful, but why not do it anyway? Here we get into the second axiom. Nothing is free. Nothing is free in this world. By adding an optimization, you pay a price in the same way that you also pay a price by not adding it. So what is that price? It can increase code complexity. In this example, if I add a list to hold all the red blocks, I now have 2 objects that refer to the same thing, the map and the red blocks list, and I need to make sure I keep them synchronized. If I were to modify any block in the map, I would also need to modify the list. I also need to make sure the list is cleared and properly recreated when the level is loaded. And let's say that you later create an entity that places blocks, but you totally forget to update this list when that entity places blocks. You introduced a bug. I know you might say that it isn't much work to keep the list in sync, but when you add up the fact that with the unoptimized version it is impossible to get it wrong, no matter what you do, and also the fact that the unoptimized version is still so fast that it is impossible to measure any difference, there is no need to optimize it. And this was a simple example. I know you will say that you can create a setter for the map to reset the blocks and keep the list in sync, but some examples can be more complex, and the more cases you have, the easier your code can break. I will do a video on this caching topic at some point. But we are not done yet with the nothing is free axiom. So this is my Minecraft clone, and for crafting, I just have a very big list of crafting recipes, and when I craft, I just check all of them to find the crafting result. Many people in the comments told me that I could use a hash to optimize it, but that also has a cost. This can be time, for example. I need to spend time implementing and testing a system like this, and that time is valuable, because it can actually be used to optimize systems in the game that are actually slow, like the light system, that really needs optimizations. And I am still not done yet. Let's say, okay, I add the hashing thing. Now, what about more complex recipes? Like recipes that are mirrored, or recipes that don't have a shape. Or maybe, I have recipes that also use the metadata of the items, or recipes that can use multiple combinations of items from a set. With my approach, adding all of these cases is extremely easy, but by adding a hash map, I also pay the price of making it harder to implement these later things. And again, keep in mind that I pay these prices for no reason. The unoptimized version is so fast that if I were to have 800 crafting recipes like there are in Minecraft and give you two versions of the game, one optimized and one not optimized, there won't be any test that you could do to determine which one is which. Another YouTuber made a video about this on exactly this crafting topic, so go watch it after this video because it's extremely good. And now, here, many people will say, what if there are like 1 million recipes? Or someone commented, what if there are 100 people on the server? Well, let's look at that case. The crafting function is only called only once when the item is crafted, so it isn't that bad. And again, I have to remind you that the unoptimized version is still extremely fast. Even if 100 people crafted an item at the same exact time, there would be no lag spike on the server. And here is the funny part. My server can't possibly hold 100 people. There's no way that would happen, because the networking system actually needs optimization, so we can't even get there in the first place. So you see what is the problem? I should focus on optimizing systems that actually matter, instead of things that are already fast. Why should I optimize the crafting system so that it works with 100 people, instead of making the server work with 100 people in the first place? And beginners just assume that something is slow without testing it. And then they say, oh, but what if I have like a gajillion players on the server? Then the code would be slow, right? To me, this is like saying, I have a car, but what if I go visit the Sahara Desert? I need to invest in desert tires and add a water tank to the car to never run out of water. And now the car is not suited for use in the city anymore. So, stop thinking about adding 10,000 items to the game. You don't have 10,000 items in the game now. And more importantly, you have things in your game that actually need refactoring and optimization. So focus your attention there and don't assume something is slow before it gets slow. Okay, one more example. In the arrow shooting thing, people might say that my algorithm is bad because it is O of n squared. So what if the map becomes very big? Well, you know what else is O of n squared? The time it takes me to make the map. The map will never become so big that any n inside an O of n algorithm in the game becomes a problem, because that would also mean that it would take me years to finish making a level. And then people might say that, oh yes, but maybe I will add in the future a procedural map creation, and at that point it's good that I optimize my algorithms. Bro, just do the map procedural creation thing first, and then make the optimizations. Now, I know that you will say two things. There are cases where you need to optimize and plan in advance. If you know you will actually have 1000 items in your game, you should think of that from the beginning. This is true, and I totally agree. But as a beginner, I see people always making their code worse when they think of this. So keep your code simple, because trust me, it will never hurt you to have your code simple. If it ever creates you problems, it's easy to change it because the code is simple. And the second thing you might say is, what if, by having many unoptimized pieces of code, the program will start to be slow? This is possible, and it is indeed very nasty if it happens, but I will show you how to never run into this problem at the end of the video. So, we have talked about high-level optimizations, now we need to talk about low-level optimizations and code Ptimization. So, low-level optimizations are doing some low-level things, like using bit fields to reduce the memory size of a struct, not putting if statements inside loops, and other things like this. So I will be quick on this one. The compiler is kinda smart. He can do some very nice things for you. I have seen a beginner put the declaration of a variable outside the for loop, so it isn't declared every iteration of the loop. So, this isn't at all how it works. There is no difference, and even if there were, as we already discussed, no one would notice it. So you should focus on code readability rather than try to do these hard low-level optimization things. So here comes the example from the beginning of the video. This is from the book The Art of Writing Efficient Programs by Fedor G. Picus. And the aim of this example is to scare you into not trying to do low-level optimizations without measuring your code. So, the author starts with this function that he wants to optimize, and he measured it, giving him this speed. He then figures out that he can safely remove the comparison, because the function will be called on substrings. So, one string will reach a 0, returning from the function, or if they both reach a 0 at the same time, That means that they are the same string, and this gave him a twice as slow function. And we are not done yet. Unsigned ints were used here because there are no negative values. But changing this to an int will actually get us to the fastest version of this function yet. Okay, so I hope this shows you that micro-optimizations are not as easy as doing something without measuring your performance. Now, to explain this example, unsigned ints can overflow, but normal ints aren't allowed to overflow. Yes, that is considered undefined behavior. Now, this first code won't overflow because we do these checks here to break out of the loop before it is possible to overflow. This other code won't overflow either, because that would be illegal. Int should not overflow. So this code could overflow, however. And this messes with some optimizations the compiler can do in the other examples, leading to a worse code. Now, if after you saw this example, you thought to yourself that you will always use ints instead of unsigned ints in for loops because they are faster, I want you to take your hand like this and slap yourself in the face. That was from me. And rewatch the video again. This is not how micro-optimizations work. I know it is tempting to take a low-level optimizations advice and apply them to your code to make it faster, but things are not as easy as they seem. For example, many people say that switch is way faster than if, but after many tests, I found that in C++ that is not true. There are very few cases where that happens. The difference is not even close to big, as people say, so I made a video about this. Finally, we get into a concept that I learned from Casey Moratori. It is called code ptimization. So your computer is fast, and by writing code in a compiled language like C++ that doesn't have a garbage collector, your code is kind of fast by default. I have texture pack support in my Minecraft clone, and it loads significantly faster than the one in the original Minecraft. They can also do that for sure, but they have to optimize it, because in Java, since every object is a memory allocation, you need to do some work to add optimizations. So for this texture pack support, I didn't do anything to optimize it. In fact, it is the worst written system in my game, but there is one thing that you need to do, and that is to not pestimize your code. This means not doing stupid things that hurt performance for no reason. So this means, for example, allocating memory on the heap for absolutely no reason, or copying an entire vector instead of passing a reference, or allocating memory in a loop instead of allocating it upfront, or making very complicated abstractions to do some simple things. So these are optimizations that are very simple to do and don't hurt your code readability that much. But if you write your code very simple, in general, and don't do abstractions and weird things for no reason, you won't pessimize your code. And trust me, in my whole 10 years of writing C++ code, it never happened to me to have problems because I didn't optimize every piece of my code. Also, the texture pack system that I talked about is very rarely used. So I didn't optimize it, but rather, I made sure it is robust. To do this, I, for example, used strings, because, while they are way slower, there aren't many of them, so I prefer to use a string and know that my code won't break from messing some raw strings thing. I know people will say that it isn't that hard to not mess raw strings, and it is true, but while doing that system, I actually needed to pay attention to managing correctly all the resources of the game. So I didn't really want to pay attention to some small few strings, instead of paying attention at literally the entire GPU resources manager of the game. Furthermore, this system will reload all the texture of the game, and that will take probably 1 or 2 seconds. So given the circumstances, not even optimizing a few milliseconds out of it would produce a visible result. So the conclusion: yes, you will need to optimize some things in advance, but you can do that correctly as a beginner. So until you learn that, keep your code simple and make simple optimizations if they are very straightforward to make. Try to put code readability first. If something causes a performance problem, you can go and optimize it, and stay away from low-level optimizations. They are harder than they seem. Finally, also keep your code simple and don't do too much abstractions. I know it is tempting to do a big class and cool inheritance, structures, stuff, but just make the simplest thing that your program needs to do, and then move that into a big class hierarchy if needed. So now, check out why Switch is as fast as if, or maybe check out this video from Games with Gabe that is on a very similar topic to this video. See you!